Hi students, I'm going to go over the lesson for this week, which is multiple representations. We were actually working on multiple representations before we left for spring break, but we never got to take our test over that. So hopefully this will all look familiar for you. Before you start the lesson today, you might want to download the worksheet that goes along with it. You can click and download it if you have a printer at home and you want to print the worksheet. You can, or you can just pull it up on your computer screen for reference, but I'm going to be showing it to you as we go through the lesson. There's also notes in the module that you can download. If you took your math notebook home, these are the notes that would apply to this lesson. So I'm going to go over a few things on there. So as you can see, this is something we did back in February. We started it, we were working on it. You guys were doing great. We had some of the best quiz grades that I'd ever seen, and we never got to take our test. So just a quick review. Multiple representations refers to tables, graphs, and equations that can all go together. And when we're looking at our tables and our graphs, there's two types of relationships that we see in 6th grade. Remember, we only do one-step equations, so you're either going to have an additive relationship or a multiplicative relationship. In an additive relationship, you are adding or subtracting to get your output. So remember, X is your input, Y is your output. So we look at our X values in the table and we're either adding something to our X values to get our Y values, or sometimes we're subtracting, but either way we call it an additive relationship. When we make our graphs with an additive relationship, we talked about in class that you will not see the graph starting at the origin. Remember, origin is 0, 0. Because it's an additive relationship, if you start with 0, you add something to it, you're not going to end up with 0 as your answer. That's why you're not going to see 0, 0 as a point on the graph. So there's some examples of additive relationships that we did in class. And then the other type of relationship you might see is the multiplicative relationship. That is where you are taking your X, your input, and multiplying it by something. And if we are actually dividing, remember, we will multiply by a fraction or a decimal instead of dividing in most cases. When we have a graph for a multiplicative relationship, that is when we will see the graph crossing the origin, or 0, 0. Because if you start with 0 and you multiply it by anything, you get 0 as your answer. So that's a quick way to tell the difference between additive and multiplicative if you're looking at a graph. We've talked about that in class, but that's a review for you, so you'll notice all of these do go through the origin for our multiplicative relationships. So if you have these notes at home, you can keep them out while you're doing your practice this week and while you're doing your quiz. If you don't have them, I wouldn't print them. It's going to waste ink, but you could have them pulled up while you're working on your quiz this week, and it might help you just looking at those graphs, figuring out what might be happening. Okay, on to the practice. Again, you do not have to print this. You can just follow along with what I'm doing on a piece of scratch paper. So our first few problems, we have input-output tables. Input is your X value, output is your Y value. So if we were going to graph this, X would be the horizontal axis, Y would be the vertical axis. But right now we're just going to focus on what is happening. So if we look at these input-output tables, this first one, we'll call this number 1. We have 2, and then we end up with -3. And then we have 4, we end up with -1. So we have our input and our output, and from our input to the output, our numbers are decreasing. The value's going down. We're starting with 6 and ending up with 1, starting with 8, ending up with 3. So we should know we're either subtracting something each time or we're dividing by something. It's probably easier to look right here at these positive numbers because it's just easier to work with those. So if I'm starting with 6 and ending up with 1, I might be dividing by 6. 6 divided by 6 gives me 1. But if I do 8 divided by 6, I'm not going to get 3. So then I'm going to look at subtraction. 6 minus what number would give me 1? Well, 5. So then I've got to see, would that work? Would 8 minus 5 give me 3? It would. And so I need to keep checking with my other numbers. Would 4 minus 5 give me -1? Yes. If I start with 4 and I take 5 away, I'm taking away more than what I have, so it gives me a negative answer. When we write an equation for an additive relationship, the format that we use is y equals x plus a. So y and x are going to stay. That represents your input and your output. The only thing that we change in our equation is the a. And the a is what is being added or subtracted. So in this case, we figured out that we are subtracting 5 each time. So when we write our answer, it's going to be y equals x minus 5. And we could also write y equals x plus -5, which would be the same thing. But this is the way you would see it in a multiple choice test. Y equals x minus 5. Okay, this next table is a little bit more difficult. We have input and output again. We're starting with 1, getting 0.75, 2 to 1.5, 4 to 3. Our numbers are getting smaller, so that means we are either subtracting something or we are multiplying by a fraction or decimal, which is the same thing as dividing. So if we look at subtraction first, 1 to 0.75, 1 minus something would give me 0.75. So we're trying to figure out 1 minus what number would give me 0.75. Some of you can do that in your head, some of you can't, and that's okay. An easy way to check is to do the opposite, do 1 minus 0.75 to see what that would give you. And if you do that math, you would get 0.25. So 1 minus 0.25 would give you 0.75. Then you've got to check and make sure that would work for all the numbers. So if we do 2 minus 0.25, that's going to give me 1.75. That's not going to give me 1.5. So we are not subtracting something. We are dividing by something, which, as I said, would be the same as multiplying by a fraction or a decimal. We have decimals already, so we need to think of what decimal we are multiplying by. So just like before, 1 times what number would give me 0.75? Well, 1 times any number is going to give you that number as an answer. So 1 times 0.75 would give you 0.75 as your answer. And if you get to use a calculator when you're in class, you can use it to figure this out. So then we need to check and see, would 2 times 0.75 give me 1.5? So I've done my math here. 0.75 times 2 does give me 1.5. Remember, when you multiply with a decimal, there's 2 digits behind the decimal point here, so you've got to have the same in your answer. So it's looking like we are multiplying by 0.75 each time. And if you go through and you keep checking with that, 4 times 0.75 will give you 3. 7 times 0.75 does give you 5.25. So now that we know that we're multiplying by 0.75, we've got to come up with our equation for the table. With a multiplicative relationship, we use y equals kx. K is your multiplier. So our multiplier here is 0.75. So when we write our equation, remember we always leave y and x alone. They're just always going to be y and x when we write the equation. Our multiplier, and y'all have to excuse my handwriting, I'm writing with my mouse, would be y equals 0.75x. So there's your equation for that question. Okay, here we have another input-output table. This one is just turned on its side. It's a horizontal table. X is still your input, Y is still your output. So yet again, we're starting with larger numbers and ending up with smaller numbers. 1 to 1/4, 2 to 1/2, 3 to 3/4, and then 4 to 1. So looking at these, we're either subtracting something or dividing by something, which again could be multiplying by a fraction or a decimal. So first I would probably look at the relationship here between 4 and 1. If I start with 4 and I want to end up with 1, 4 minus 3 would do that for me. 4 minus 3 is 1. But if I look at this next set of points, 3 minus 3 would not give me 3/4. 3 minus 3 would give me 0. So I can rule that out. I'm not subtracting 3. So now I've got to think about division. If I take 4 and I want to divide it by a number to get 1 as my answer, well, 4 divided by 4 would give me 1. So now I need to check that for my other sets of points. 3 divided by 4, that would give me 3/4. Now we have 2 divided by 4. So if I take 2 and divide it by 4, remember we can write division as a fraction. Just like I could write 4 divided by 4, just like this, I can write 2 divided by 4 and it would look like this. 2/4 is the same thing as 1/2. We can simplify that fraction, divide the numerator by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So 2/4 is the same as 1/2. So that dividing by 4 actually works out. And then if I'm checking my rule still, 1 divided by 4 would give me 1/4. So it looks like in this table, I'm taking my input, my x, and dividing by 4 to get my output. Now this is a particular problem that we could write several different ways. So if you've done this on your own, you might write it different ways. So this would be acceptable. I actually wrote it backwards. It's supposed to be y equals kx. So you could write y equals 1/4. X multiplying by 1/4 is the same as dividing by 4. Y equals x over 4 or x divided by 4, just like what I did a second ago. And then if you wanted to use a decimal, I probably wouldn't do that, but if you wanted to, it would be y equals 0.25 x. So any of these would be acceptable for your answer to this table. Okay, moving on to one with a real life situation. So in this next problem, we have a table that shows the relationship between D, the money that Alice has at the beginning of the day, and W, the amount she has after riding the bus to work. So we're starting with a certain amount of money, paying a bus fare, and then we have a certain amount left. So we're trying to figure out what the relationship is here. So first I would just look at how the value's changing. Remember, input is our X, output is Y. They've changed the letters on this table, but that's okay. We should know that input is always on the left, output is always on the right, or input would be on the top and output would be on the bottom. So if we start with $15.75, we pay the bus driver, we end up with $14.50. Start with $9.50, end up with $8.25. Start with $5.25, then we have $4 left over after paying for the bus. So our value is getting smaller, which makes sense because if you're paying for something, you're going to have less money in your wallet after that. So this one gives us answer choices. It makes it a little bit easier. So we're going to go through the answer choices and see which ones could possibly make sense. If we look at F, D is our starting amount. So if we look at one of these situations, $15.75 would go here, plus $1.25 would give me $14.50. That does not make sense. We would not add and then end up with a smaller number unless we were adding a negative, but we're not. We're adding a positive 125, so that does not make sense. G says we're multiplying our D value, which is our input, by $14.50 and adding $1.25 to get our W value. So if we look at a value from the table, that's like multiplying $9.50 times $14.50, which is a lot, and adding $1.25, and then you'll get a value that's less. That does not make sense. Similar with H, we're multiplying by a very large number. That's not going to give us the answers that we need. So then on to J, we take our D value. So for example, $5.25, subtract $1.25, and we get our W value. $5.25 minus $1.25 would give us $4. and that relationship continues, we're subtracting $1.25, so that tells us that's how much she's paying for the bus. D would be our answer there.